Okay, so after we initiate the import the important function and also the library, um, we list out all the columns of the data frame to see what are the columns contain. So there's a lot of food products, different kind of food products in their own respective category, but we can further like group them into a larger group. So here we have like animal feature, uh, vegetable feature, sugar feature, and stimulants. So in this data frame, right, we want to predict, we want to see like how the supply of the food will affect the death of the COVID-19 in a country. Okay, so here we create a data frame and put every features of interest uh, inside the data frame, and then we plot a pair plot to see how the bigger category that we just grouped them, how are they related to death. And we also plot correlation metrics to see their correlation. Yeah. And here we can see that along the death column, the animal and also the plant has a higher correlationship than the sugar and stimulants. Okay. And then we go on to clean up the data frame, and we separate into the features data frame and also the target data frame, the depth. So, okay. And also we plot each features with the depth to see their relation with the depth individually, and to make sure that they have some relation before we use them in our model. Okay, so after we do our gradient descent, we got this beta value, and we go and predict, and we obtain this performance metrics. So the metrics we'll be using is mean square error. So here we have 0.000379, which is relatively low. And do keep in mind that this errors is in terms of like a proportion, the percentage of death. Okay, and we also are interested in the adjusted R square, because later on we're going to drop some features to see whether there's a change in this adjusted R square or not. Okay, so next step is that we remove the other two features. Like we mentioned that because animal-based and plant-based has a higher correlation than the sugar and the stimulants. Okay, so we removed it, and then we check to see their mean square error and the adjusted R square. So we see that here the adjusted R square is actually decreased, which means the added new feature of the sugar base and the stimulants actually helps to improve the accuracy of our model. Okay, so we'll keep that. And also it's because that with the reduce of that two features, our mean square error actually increase, which means it's a worse metrics. Which means this second iteration is actually a worse models.
Next, I'll be explaining task 2. In Singapore, the government has placed a lot of emphasis on the healthcare capacity as a metric to make decisions about the relaxation of COVID-19 measures. Hence, for task 2, we wanted to create a model that predicts the number of hospitalizations given the number of confirmed COVID-19 cases detected. When the number of cases change, the government can use the model to forecast the pressures on the healthcare system to either expand healthcare capacity accordingly or determine whether to relax or tighten COVID-19 measures. We chose a dataset that is updated daily about the COVID-19 situation in Singapore. This dataset has a good number of data points to use for our regression, and is reliable as it collates data from the Ministry of Health. We have chosen the number of confirmed COVID-19 cases as a predictor for the number of cases still hospitalized, as it will make a good, useful model for the use case I've mentioned, together with the strong correlation shown from the correlation heat map that we have plotted. Since we have to repeat the model testing process, this process is split into 5 different functions. CleanDF cleans up the data and returns a combined data frame of both the feature and the target. PrepareDF obtains the feature and target data frames from the combined data frame. Test relationship tests the model and obtains a set of beta values for the regression line, as well as the metric scores. Repeat test repeats the test relationship function multiple times to find the average metric scores. And lastly, visualize beta plots the dataset to the regression line to allow us to visualize the accuracy of the regression line. After we have initialized these functions, we can begin the iterations. We run the 5 functions to obtain the values and plot here. The initial average values of the metric that we find do not suggest a very strong correlation. However, from the graph obtained, we can see that the scatter plot follows a curve. Hence, for iteration 2, we take the feature as a square root of the daily confirmed cases instead. By changing the prepare_df function, we do the required transformation. This iteration shows better metric scores and a much better relationship shown on the scatter plot. For our third iteration, we drop the outliers on the y-axis observed from the scatter plot to further clean up the data frame. Running the same model, the results obtained shows an even more improved metric score. Thus, the equation of the regression line is shown here. Based on improved metric scores, we can conclude that the model is reasonably accurate to predict the number of patients still hospitalized, using the number of COVID-19 cases.
Hello profs, welcome to our 2D project. We are group 1 from FO8 and we have created 2 regression models. Task 1 predicts the number of COVID-19 deaths based on various factors we have identified. And Task 2 identifies the number of beds needed in hospitals based on the number of COVID-19 cases in Singapore. Over here we use the slider bars to adjust we adjust the slider bars to explain the percentage of our diet, and we explain the percentage of the population that has or has had COVID-19, and that helps us calculate the percentage of the death rate in percentage. In task 2, we calculate the number of hospital beds. This is done to assist the government in planning the number of hospital beds that are needed during a surge in COVID-19 cases, and hence be prepared for the future. As you can see, we have predicted the number of beds for 5374 cases as 1833 beds. Thank you. I hope you have enjoyed.